that look good?
So very warm welcome to those of you joining us today. I'm just going to wait a minute or so to let everyone join this session. Again, a warm welcome. I'm just going to give it maybe 20 more seconds to let folks come in. We did have a good number of registrants. I want to make sure many folks are able to join before we get started.
So popular, Melly, you're already getting shout outs in the chat.
Yeah, hi Pablo. Let's get started in a few seconds here. Okay, I see the number going up more slowly. So I think we can get started, Jason. So once again, a very warm welcome to all of you who have joined us here today from all parts of the world. We are really excited to have Jason Duncan-Wilson speak to you today about the work he and his team are doing with respect to working with data from multiple sources, harmonizing the data, and then doing some really cool stuff with that data in terms of generating human readable text and so on. And the core technology in all of this is knowledge graphs. And that's why I'm part of this session. You may know that I'm a product manager for Oracle Graph. With that next slide, please, Jason. So if you're new to this community, I would like to highlight that the Analytics and Data Summit community is a very vibrant community for folks who are interested in all things data and all things analytics. And there are a bunch of events that this group organizes. And here we have, I'm just highlighting here the various TechCasts that are periodically organized, and previous web TechCasts are archived. You can always go back and look them up. Lots of interesting topics are covered, so do check out this archive. Next slide, please, Jason. And if you're already a member of the community, you would know all of this cool merchandise designed by other members of this community that you can buy to declare that you are an analytics and data geek.
Yeah, I hadn't seen this yet. I love the paranormal distribution one.
That is cool. That's cool. Thanks to Haley, I think, for designing that. Next slide, please, Jason. And we have a bunch of social media channels where you can connect with us, Oracle product managers, other Oracle users, various folks are on these channels. You can have discussions, ask questions, and so on. So we invite you to join these channels. And next slide, please. And the final thing I'm going to say before handing this off to Jason is the live event, which is held annually, typically in California, the Oracle Conference Center, that is going to be held this year between April 9th and 11th. We have lots of interesting sessions, hands-on labs, and on various hot topics like Gen AI, Generation AI, machine learning, graph analytics, and so on. And the full agenda is now available, so I really hope you can join us. So with that, over to you, Jason.
Awesome. Thanks, Melly. So I'm Jason. I lead a team that's building a new service, the Industry Data Exchange at Oracle. And I'm going to go through some slides first, really give some background into what we're building and why, and talk about some awesome features of autonomous database that we're leveraging. And then I'll spend a lot of the time demoing. So first off, why are we building this? The energy industry is going through a massive transformation right now. For the last 100+ years, energy was delivered in kind of a one-way direction. Power was generated, consumed at a household. Everybody at their homes are consuming energy. That's about it. But it's getting much more complex nowadays. There's really a two-way grid going on where distributed generation is much more prevalent. Solar panels, batteries, electric vehicles are making things more complicated. So human behavior and how different loads on energy production at the home or in distributed ways is really making things way more complicated. So we know that in order to make sense out of that in this new energy economy, we need to find a way to better exchange data between lots of different parties in the industry, starting with utilities also getting their data in shape internally and focusing there. I'm giving the background because I want you to understand why we kind of went on the journey we did and why autonomous database was so key, but I'll get into the details really of all the tech we're using behind this. To go at this problem, we really had to start with, okay, what's the main problem? The main problem, although it is a great thing about transactional systems and enterprise systems, is that they're optimized to solve a very specific problem. And that's really their goal in life. But that leads to very specific data models to that problem, siloed security. And so we end up with data that looks very like transactional, often like code based in nature. We'll look at some of that in the demo. But to connect the energy industry as well as other industries, we really need to get to intrinsic meaning in data. And what I mean by that is really data that has meaning independent of context. So data that anyone could decipher coming out entirely fresh. They wouldn't need like the decoder ring to figure it out. You'll see some of that here in the demo in a minute. So we built or are building the Industry Data Exchange. We're launching it later this year. And this is all about bringing data in from any source, standardizing it to an energy and water industry standard model. We leverage the knowledge graph in the autonomous database and put an ontology into it, which you'll see. And then we're focused on like kind of a simplified publish subscribe model. So I'll demo all of that. This is a big landscape with a bunch of boxes and a lot of things going on here. The specifics of all the different pieces I don't want to get into, but I want you to focus on the left side, which is data wrangling, and the right side, which is data mining. So, AI, analytics, everything that is about getting the intelligence or insights is on the right. But it's super important to get the data right in order to power that. So that's our focus with the data exchange. We're getting data wrangled into great shape for teams so that they can get faster uptake, speed to value on the data mining side, but also make it super easy to share across the industry. And the way we do this, again, like transactional system data models, they're really optimized for transactions, which is awesome. That's where I've spent most of my life in software. But the con is that they're full of cryptic names. The data is often very normalized and also very code-based in terms of shortening and connecting things. What we're focused on with these industry standardized models are optimizing for data sharing, optimized for immediate understanding of that intrinsic meaning. And the way we get there is with an ontology. And the way to think of an ontology is really the nouns and the verbs of an industry. So what are the things that we're using or have in the industry? And what are the things they do between each other? So taking the data from the various systems, applying semantic meaning and linguistics to it, allows to come to that true intrinsic meaning and make it easier to share, easier to prep for machine learning, especially generative AI. You'll see some of this come out in a minute. So this is a quick example. So you can see very abbreviated kind of cryptic names of columns down here, often codes to different things that are abbreviated. Once we put it through the ontology, and the data exchange, we were able to actually put out language-like output that's awesome for generative AI. We've got layers to this ontology, so you'll actually see that in demo as well. We have concepts that are common across industries, and then concepts that are specific to each industry. And all that data needs to make sense in terms of an integration spec coming from those raw data sources. So this is where the autonomous database and the fact that we can use relational, graph, and JSON data all in the same place seamlessly is what's given us that power, to achieve these results. So relational, in terms of coming from these enterprise systems, is still crucial. Most of the data in enterprise systems is in relational form, often in third normal form or some other denormalized form. So we still are very focused on relational data, but have normalized it and flattened it as a good interface for ETL and mapping data from sources. And then the graph is really what allows you to get to that like connections and network and come up with new things that you couldn't otherwise because of the depth of the connections that are needed. So an example of this in the energy industry is a few different domains: customer and billing, operations, the electricity grid. When we look at these, when we look at an ontology and a knowledge graph, the first thing we need to do is find the connective tissue, the things that really make it all come together. And once we do that, the stuff in the red in the middle, once we've connected things, then we're actually able to go outside of what we're typically focused on with our utility customers, which is to start to branch out to all the things that are emerging in terms of technology and trends out there. So this is where the knowledge graph becomes key, because in this demo, you'll see 5 different sources coming in. Some are utility sources, some are from the Department of Energy. All that needs to come together in a set of knowledge graphs, an autonomous database, and all connect up and make sense. All right, so quickly, I want to reflect on the vision of where the Oracle database team, Melly's team, and everybody else on that team is really focused. So the key here is to make it easy to develop and run modern apps and analytics for all use cases at any scale. And my team can attest to this really coming true for us. So we've been able to take advantage of the converged nature of autonomous database, the fact that all different modern data types are supported, and truly, it's the sort of thing where you can spin up the database, all the things you need are in one place, and we're able to move super quickly as a team that's trying to approach a brand new problem space. And again, within that same one, within a single database, we're able to move interoperably between relational, row-based data, a graph as a network, and JSON as hierarchical to get to these cool new results for the industry. A couple features you'll see, I've got a few more slides and I'll jump over to the demo. A few features you're going to see us focus on are in the autonomous database are bridging graph to SQL. So this is the semantic match query capabilities of the autonomous database. This is truly being able to query the knowledge graph, but surface that in SQL. You'll see connected graphs virtually. So we actually create an independent knowledge graph per source that's coming into this data exchange, but then you're able to knit them together virtually, which I'll show. We also are taking advantage of a somewhat new capability of autonomous database, which is geocoding that's natively in there. So recently there was a release to get a geocoding service natively in the database. And it's pretty awesome to not have to leave the database. So I'll actually show that as well.
And that's one of the cool things, Jason, I like about what your team is doing. You're using the graph capabilities and the spatial capabilities, and perhaps Jason, other things in the future, all in the same database.
Absolutely. And it's allowed us to move super quick as a team. So it's been great. So ultimately, we're focused on getting more data in more places for utilities, both internally and with their trusted vendors. And we're accelerating kind of the lifeblood of analytics and AI with getting data in shape. So I'll show all this in the demo. So here's a quick view of like what you're going to see in this demo. So like I said, you'll see 5 different sources. Those are all shown on the left. There's customer system from a utility, a grid system. There's a customer engagement system. There's data from the Department of Energy. So lots of different sources coming in. What you'll see in the autonomous database is I'll show I'll start with showing the raw data, and I'll show some of the standardization we do in terms of like kind of the relational way of normalizing data. And then we go straight from that normalized form on the relational side into the knowledge graph. And I'll show the knowledge graphs that we're constructing an autonomous database and some of the ways we're able to bridge the knowledge graph and SQL side of the world. And then just for fun, I'll show you some of the data in Oracle Analytics Cloud, because showing off data in raw form is nice, but it's not as visually interesting as showing it off in an analytics tool. So let me jump over to that. While I'm switching this, Melly, are there any questions?
Yes, there is a question. Is the graph database a property graph or a knowledge graph?
Yep. So what I'm going to show you is an RDF, or yes, a knowledge graph that has an ontology baked into it. Okay. So first thing I want to show you is just to give you context of the service we're building. So this service is in OCI, which is it's a native service in OCI. So you're able to go in, you're able to create a data exchange. And this is just giving you context for some of the stuff you'll see in the demo with the data. So let's say a customer team at a utility decided to spin up an autonomous database within the data exchange. They'll actually have what we call data assets, where they're pulling in lots of different sources. And within those data assets, you're actually able to like further standardize different collections. So I'll show some of this off. I'm not going to focus on this a ton because I really want to get into the depth of the data and what we're doing on an autonomous database, but just some context that the data exchange is a service. It has a data store to it, and there can be lots of different sources where we standardize collections for those sources as part of this. So I'm going to focus first on the actual data. I want to really stay deep on the data for what I'm showing you all. So again, like I was mentioning, I'll start with just showing off. We've got lots of different, there's like data from the Department of Energy, from O-Power, that's our customer engagement system, from our customer system, from the grid systems, so lots of different stuff that's been staged in here. And I'll just first show some data for a person that's coming in from the customer system. 1 second, let me refresh my connection. Sorry. Give me 1 second. Something must have happened while I was presenting. Sorry.
Well, that's what makes live
I know
demos interesting.
live demos are always, yeah. All right. I'm just rebooting my connection real quick. I think there's a few more
After you do
questions
that,
that I can
Jason,
answer while
maybe,
you're.
yeah, there are a couple of questions. One, is the OCI data exchange feature generally available?
So this isn't available yet, and later this summer we'll be going into limited availability, and then we'll be aiming for GA later after that.
And there's another interesting question, like the data collection data asset in OCI, is that specific to oil and gas or energy or your industry?
So
And I guess I'm going to extrapolate the question. Can it be
yep.
used for other industries as well? Yeah.
So nothing about the service is actually industry specific. It's really the models and the ontologies within it that are industry specific. But yeah, you'll see the depth of the industry focus in terms of the model and the ontology. But yeah, nothing about the data asset or the collection is industry specific. All right. Again, sorry for the live demo hiccups. That's how it always goes. Okay, so back to querying the raw data. This is the person data from the customer system. So this is just really broken out data like you'd expect. Transactional, it's got different codes for the data, and it's actually in 4 different tables because it's super third normal form. So one table is the person. It's got some details about their name, contact details, and a different table again with like different codes that you'd have to interpret. IDs with different codes you'd have to interpret as well. So first step in terms of us getting this to a form that makes sense for sharing and making sense between groups is to get it in that relational form that's super normalized. We're tagging every single row that comes into this with a source ID and a universally unique ID, and then getting all the data to the point that it's super flattened, super easy to understand exactly what it is, and also matching up to the ontology. So that's just showing you the person in relation to that raw data. I'll show you a few other examples. So that was data from the customer system. This is data from the grid system. This is the service transformers coming in along with their addresses, where they are, everything. These are the piece of equipment that's outside your house that services in terms of delivering energy to your home. And then we'll look at just normalizing data from the Department of Energy. So these are the EV charging locations. And again, normalized, matched up to the ontology, super language focused in terms of the what's in here. And I want to build up from here because it's going to get complex here in a minute. So first you saw the raw data, standardized data, nothing too crazy yet. Next, I want to show you what we do as we bring various locations into that normalized relational data. So this is a view of an audit using the geocoding service natively in the autonomous database. We are auditing the street addresses for 7 or 8 different standardized shapes that are coming through, and they're all spit out into this output table. This match code here that comes back from the geocoding service tells you how good of a match it was. So in the case of a match with a 1, that means it matched well enough that you can leave it as is. You can see in some cases it came back with an abbreviated version of street. So Church Street, it abbreviated to Church ST. But in general, the 1 means that it is a solid match. When we get down to the 2s, that's where we actually find stuff that would be worth correcting. And again, this data exchange is meant to be a system of reference. So where we do these audits on the addresses, it's really, okay, go back to your source, take the list of addresses that maybe should be updated, go change it in the source, let it flow back through to the data exchange. But you can see here, this match of 2 caught an instance where Markley Drive Northwest should have been Markley Street Northwest, or in this case, this address needed a Southwest on the end. So catching little nuances of the address that need to be standardized in order for it to be accurate. And again, that was just using the geocoding service natively in autonomous database. So once we've got data that, like in its raw form, that's standardized in a normalized form, and also we've done some validation of that data, including like some of this address auditing or regex type validation. Then what we're doing is pushing that data into the knowledge graph. And I want to show you over here on the left what these knowledge graphs look like in the autonomous database. So what we're doing for the different sources is we're actually building a different knowledge graph by source. So under regular models here, under the RDF semantic graphs, you see the C2M data, O-Power, NMS, Department of Energy. That's a knowledge graph that's built off of this relational data that's standardized per source. In addition to that, for the energy and water industry, we've built an ontology that we've injected right into this ontology knowledge graph. And I'll show some querying of these in just a second. But on the virtual model side, that's where you can actually knit together various graphs. So this one that's knowledge graph, or KG C2M, that's actually marrying together the C2M data and the ontology as 2 different knowledge graphs into one virtual graph. Or this knowledge graph all is actually taking all 5 of the regular models up top, the regular knowledge graphs, and virtualizing them into one that's queryable. So go
So
ahead.
there was a question, Jason, I just want to highlight here is the question was, what is the ontology you're using? And I think you created this ontology, I believe, and I think
Correct.
you'll be talking about that a little bit. Okay.
Yep, we're curating an ontology for the energy and water industry. And actually, we're next looking at the construction engineering industry after that. But we're starting with energy and water only. And it is an ontology that will be curated by Oracle, injected into this service as a way to make sense out of all the data. And it always matches the different entities we have going on. So I'll actually show briefly an example of our model, our standardized model. And this is a preview of the documentation that'll be on docs.oracle.com. So we look at something like the distributed energy domain, the electric vehicle charging locations. Everything here is called out in terms of the relational form, but it also connects over to like what related graph object it's actually related to in the knowledge graph within the service. So we have this for every object that will be standardized in the energy and water industry. Yeah, and again, this will all be published on docs.oracle.com as a nice way to connect all this up to think about it.
So
Go
maybe this
ahead,
is
Melly.
also the right time to ask another question is, how did you convert the relational database to the graph?
Yep. So we're using a variety of the built-in tools that Autonomous Database has, like the RDF views, and then we're also just writing native translation with some of the SQL and some of the semantic match capabilities in the Autonomous Database. So I'll show this semantic match query next. What I want to do actually is start with just clicking into the ontology knowledge graph. And what I'll do is I'll go grab a Sparkle query. For those that aren't familiar with Sparkle, Sparkle is the query language of RDF graph. And this is an example of it right here. What this query is going to return is just the different classes that are in our ontology. So you can see here, there's concepts from everything from wind turbines to service areas that utilities service to all the data coming from a utility like an account and a customer, and then solar. So this is really pulling in, we built the ontology. It's got all the kind of intelligence connecting up the data from relational form to the knowledge graph. And that's all injected into this ontology knowledge graph. So that's just a first view of just the concepts within this ontology. Next, I actually want to show another Sparkle query, which is, it's a much more complicated query, but it's a query that actually pulls back all of the electric vehicle models within the ontology. Let me run this real quick. And what this is going to do, there are electric vehicle models that are from the Department of Energy. We've injected those models into the knowledge graphs. You can see, a Tesla Model X Plaid. You can see a Rivian R1T. All these models, plus the intelligence of, how large the battery size is, fuel economy, range, all that kind of stuff is in the ontology and in the knowledge graph, so that you can pull that in and make sense of it. And you'll see here in a minute. For everything we need to do in our industry coming up, we send out surveys to customers to understand what electric vehicles they have, but understanding the guts behind that of like, how does that electric vehicle impact the grid in terms of true battery size and how much energy it pulls is super important for planning and making sense out of the impact that's going to happen to the grid. Now I'm showing this before I go to one second.
Sorry, I thought there's a question which might be relevant here.
Okay.
And I don't fully understand. I'm just going to read it out. Can utilities companies with their third-party CIS system take advantage of this, or is it limited to energy and water app sources?
It's not limited to just the Oracle energy and water sources. So all of the different models that we're talking about here and the ability to standardize these different shapes of data, they're not specific to the energy and water, Oracle energy and water systems. It could be, from an SAP CIS. It could be from Maximo as a grid system. So yeah, nothing that requires it to come from energy and water apps. So I'm showing off this vehicle model one because in a second I will show you the semantic match side of this. Before I show you the semantic match side of it, I actually want to switch over to showing a little more of what happens on the other side of this. So when we get data into such great shape in terms of everything I've been showing, you can actually start to do pretty incredible stuff with it. So right here, first, this is a view of the language output that we can get by getting data into such great form in the knowledge graph. So on the left is an ontology language like output. Again, you were seeing the concepts that were in there, like electric vehicle battery capacity class, energy unit, all these things are concepts in the ontology. This is the language output of that ontology. And then on the right, you're seeing the actual language output from the knowledge graphs from those 5 different sources we were talking about. So in this case, let me go find something different to filter on. So let's look at electric vehicle charging location, because that's cool. So every electric vehicle charging location in the United States is in this knowledge graph. And you can see here, this is the language output of that. Now, why does this matter? Why does language output matter? We started this data exchange project before generative AI and LLMs were so hot. But it was kind of an awesome timing, almost happy accident that they're so hot now, because this language output is awesome for training industry-specific LLMs and generative AI, which we're working with the OCI Gen AI team within Oracle to start working on industry-trained LLMs. Next, I just want to show an example of all the data that's in that knowledge graph and in the standardized relational form for the grid. So again, I started with that one-way grid versus two-way grid. This is a view of the circuits coming from the grid system, from our NMS system. And let's look at like circuit 2612. So this dark gray color is the circuit coming from that's feeding a whole section of what a substation feeds. And all these individual dots are the transformers. This is the equipment that's right outside your home that feeds you electricity. So the view we need to be able to get to for this is a view where you have that view of the grid, like this circuit, like we were just talking about, but you also have all the electric vehicle charging locations, all the red dots coming from the Department of Energy, all put together, and you have various sources of understanding distributed energy resources. So in purple, you're seeing a variation of wind turbines, solar, and electric vehicles, all detected or from various sources that are being brought in. And again, like the key here is to understand which circuit on the grid is going to be most impacted by the adoption of these different devices. Let me pause there, see if there are questions.
Yeah, there are a bunch of questions, and I just want to highlight before the questions is that you would not get this kind of a comprehensive view or kind of a summary view if you didn't do the core job of integrating the data. It's because the data is coming together that you're able to get this kind of combined view that you're able to.
That's exactly right. And after I show some of these fun visuals, I'll go back to the data again and actually show some of the more complex knowledge graph queries that we're doing that back these cool visuals.
Okay, that sounds great. So let me just ask you a couple of quick questions. There are a few questions. I'm going to ask 2 questions related to the service, and then we can answer the rest later. So related to the service, the question is data exchange service. Is it only for OCI, ADB, or is this also can it also be used for on-premises databases?
It's only an OCI service. Yep, it won't be on-prem.
And the fact that it uses ADB is really behind the scenes, right? I mean,
correct.
That's not something
this is really the power of autonomous database and everything we've done at Oracle with OCI, because the service that Melly's team has built is so awesome that it's making my team move faster, and we love using it. So it's backing the service, even though it's really just behind what the data exchange is doing. Yeah.
Another question related to the service is, will this be used for energy and water data intelligent platform?
Yes, it will be integrated with that, and that team is team's in the same organization as me, so we get to have fun talking about all the great things we get to do with data together in that way. So
Okay, so the rest of the questions, I just want to let folks know that I will get to them at the end of the session, but for now, I'm going to let Jason continue.
cool. I'm going to show two more fun visuals, and then I'm going to go back and show kind of some of the complex queries that are behind making things like this grid, distributed energy, electric vehicle charging location come together from a knowledge graph standpoint. So again, part of the key here is not just to focus on data that we can help with utilities, but to bring in data from the rest of the world. So this is an example of bringing in data from the Department of Energy. Again, like this is all the electric vehicle models you saw earlier. But the key that I was talking about is that you can see kind of just the difference in the range here. So like some of these vehicles, let's take a look at one of them. Like the Tesla Model 3 long range all-wheel drive, has an electric range of 353. Whereas if you go down to some of these plug-in hybrids, their range is like 32. So, talking about this like Pacifica hybrid, if somebody like indicates they have one of those in one of our online surveys for customers, that's a very different impact to the grid than some of the electric vehicles that are true battery uh, full battery electric vehicles. And then again, looking at the EV charging locations, pulling all of them into the knowledge graph and into the data exchange allows us to get a pretty awesome view of what's happening, pretty holistically for a territory. So this is a heat map of all the EV charging locations in the U.S. Again, this is coming from the Department of Energy, but we've brought it in, standardized it, allowed it to connect to utility data. And as a result, you can get a lot of new insights out of this data. And I just like showing heat maps, so I gotta at least work that one in.
This is amazing, all the things you can do when you actually bring data together, right? And in this world of generative AI and stuff, it's so important to bring data together the right way, with the right
Yep.
meaning and the right context.
Yep. So I started when we were looking at data, I started by just showing you the raw data, the standardized form, just some examples of that, validating. Now I want to talk about some knowledge graph queries that are quite complex, but they bridge the knowledge graph over to SQL. So this is going to be built into the service. This is a person to electric grid view that'll be built into the service. And this is the type of view that's powering that view that I just showed a minute ago for that grid connectivity, where you saw the grid nodes and then you saw distributed energy, you saw EV charging locations. The fact that we need to marry, customer behavior over to where they're served on the grid. So this is an example of this. If we look at Oscar Baum right here, you can actually, this is a view that has been very challenging for us to get in the past because this data is coming from 3 different systems. So this is all being knit together in a knowledge graph, and then you have a single SQL focused output of this. So you can see it's connected to a transformer, what circuit, what substation, and the address, everything you need to really get that kind of flattened view of what customers are impacting the grid and vice versa, what devices they have are impacting the grid, and what characteristics of their behavior are going to impact the grid as well. So I want to do a deep dive on this one for just a second. So if we come down here, I've come down to the knowledge graph schema and the autonomous database. And this is the person to electric grid view. It's actually set up as a materialized view in the database. Again, this is the data it's pulling back. And when we look at the SQL for this, I want to go into this in some detail. So I was showing you Sparkle queries before. What you see here in this blue color is a fairly complex Sparkle query that we've written to do this connectivity between customers and the grid. And the fact that you can go down different aspects of network data in the knowledge graph makes this much easier to, even though it looks like a complex query, it's much easier to write and something that can be achieved only in a knowledge graph, in terms of this kind of ease. And so we got this Sparkle query. It's pulling back all the results you saw, but the semantic match capability within Autonomous Database is that way that you bridge the knowledge graph queries over to SQL. So it's really flattening it out into an awesome to use or easy to use, SQL materialized view. So, just like I was showing you a second ago when we query, it is just truly another materialized view in the database, but it has a knowledge graph query behind it. This can also be done with the views, with just regular views. So again, these views up here, some of the stuff I was showing you with electric vehicle models, it is a knowledge graph view, but it is encapsulated by SQL. So that's really what bridges the knowledge graph world back to SQL and vice versa. We've taken very deep advantage of this in Autonomous Database. So the person to electric grid was the view we were just seeing. We're also building a customer 360, a location 360. So all these things where you either need really wide things across a network of data, that represent the real world, or depth in terms of things spiraling out from a particular customer or location. That's where the knowledge graph has shined incredibly.
And just a detail, you're running all of this in SQL Developer. I mean, now you're running SQL. You also are running the Sparkle queries, right, in SQL Developer. So we have a Sparkle
Correct.
plugin for
Yep.
doing
Because
that.
if I go in here, any of these Sparkle queries, like, if we look at this Sparkle query that's in, the semantic match view, I could take that and plug it into my KG all, my knowledge graph all that knits together all 5 of my sources plus the ontology. And that's how we get that result. And actually, when you look down here, you can see that it's pointing to that specific KG all knowledge graph that brings all the sources together. All right. So that was most of what I had to demo. I'm going to go back to this. There's other stuff I can go back to or look at again as needed. But are there other questions, Melly, that we need to get to?
Yeah. So I think I'm going to let me ask some of the questions. So one question was, how large were these graphs, that the ontologies and the knowledge graphs you created? Do you know that off
Uh,
the top of your
I
head?
don't know that off the top of my head. I can tell you that a variety of the sources that we pulled in were anywhere from a few hundred gigabytes to a few terabytes. So I actually haven't taken a look at exactly the amount of data that turned into in the graph yet that I can answer that exactly. But some of the sources were hundreds of gigabytes to multiple terabytes. So.
And then there's another question. So I think the questioner is treating the knowledge graph that you created as materialized views because you have the data that's been added to integrated with the ontology. So I think the question is, are these updatable materialized views? But they're not really materialized views, so they're definitely updatable. They're just standard data objects in the database.
Yep. So the reason we use materialized views for a couple of the really complex knowledge graph queries is because we want them to perform in milliseconds. So, they are very sophisticated queries. You're traversing a big network of data and lots of data. So the query, like the Sparkle query itself, takes, I think about 120 seconds to run. So it's a case where we chose materialized view because just like any type of caching of things, you don't want your queries to be taking 120 seconds. You want them to take milliseconds. But it is in the product itself, it will be updated very frequently in terms of constant refresh of that materialized view throughout the day.
Right.
Yeah.
And I think that also answers another question is how much data is moved to ADB or is this all federated? For performance reasons, you do move this data into ADB.
Yep.
Into Autonomous
Yep. All
Database.
the data is in Autonomous Database. And with, like I was showing with the data exchange, you can actually, you can have multiple data stores if you want. So the data store is just backed by an autonomous database. So if for some reason you wanted to have different, autonomous databases for different sources, you could. So
Right. And then there's a question, what is behind this service for replication? Is it Golden Gate or autonomous database features? Only when have you, I don't know whether that part of the service has been built out yet.
so we're actually, because we're building it as a pure OCI service, anything that works in OCI can get the data here. So if you want to use Golden Gate, OCI Golden Gate, if you want to use Golden Gate on-prem to push to OCI, if you want to use OCI data integration, or if you just want to, if you have your own enterprise ETL tool that you want to use to get data here, all of that can plug into OCI natively. And because the service is built as a native OCI service, all that data can come in as a result. So it's a little bit of pick your poison. and then there's patterns of how to plug into the data exchange that we'll have in our documentation.
So then there's another question. Can you talk about how you set up the ontology in the first place? Was it human built or extracted from relational data? That's an interesting question.
That is a good question. So I've never gotten that question, so I need to reflect for a minute. We definitely started, it's very human built to start with, but we've built automation to maintain the ontology that we knew was necessary to keep up with the speed of change. So a lot of that is kind of core, more like design time tools that we use within Oracle, just within my team to build it. Like once the ontology is ready to be part of the service. But to answer the question very directly, yes, it's partially human constructed and then part like heavily automated after that. We use, typical ontology tools to manage it, including Protege. So I hope that answers it. But yes, it did start as human constructed, and then we've built a lot of automation around it because we'd never be able to maintain it otherwise. We do have one ontologist on my team, and he's able to handle all of this with the automation we've got. So otherwise we wouldn't scale.
Yeah. And then there's a question of, do we need to use only JSON? Yeah, not at all. I think your examples, some of them use JSON, but yeah,
Yep.
I don't think that's a requirement.
Right. So to go back, like this is an example, like this person object. It's an example of having basically the interface into the data exchange is a relational flattened view. And again, like this documentation is really trying to tell you what that interface is in terms of a flat relational standardized way of getting the data in. And then once it comes in that form, all the automation within data exchange gets it into the knowledge graph for you automatically as part of the service.
And somebody's interested in knowing whether there are any hands-on labs on this. I am, well, definitely, I'm sure you'll have labs to show people how to use the service.
So because the service isn't launched yet, there aren't any labs that are live yet. But when the service is launched, we'll have all kinds of hands-on starter material for you to help you get started and take some of this up, including having example data in there for you to leverage.
And then do you have a technical architecture for how this will be included in the data intelligence platform? It's the same person who asked about the data intelligence platform.
Yeah. So when we launch, we'll also have a reference architecture out on the Oracle Architecture Center that explains some of these touch points of integrating, not just with your sources coming into it, but also connecting data exchange into other parts of the stack, including the data intelligence platform that the energy and water team is focused on. So not yet, but yes, we absolutely will.
There are a couple of questions in autonomous database that I think I'm going to try and answer, which is
Awesome.
why do you call it an autonomous database? what specific aspects is it controlling. The point about autonomous databases, it is self-patching and self-fixing of security issues and self-updating and so on. So in other words, all the stuff that humans needed to do to manage the database, to tune the database, also self-tuning, all the things that you needed to do to tune the database to make it run fast, all of that is done automatically for you. So that's why it's called autonomous.
And my team is a perfect example of that. We do not have a DBA on my product team within building the service. So autonomous database, as I put data in there, is tuning, doing all the like Melly said, all the patching, and all we have to do is like spin it up, spin it down, and watch for those different patches coming through, like the windows. So
right, so you could focus on building this great service and not on
absolutely
worrying about the database.
And it's not to say that I don't have people that don't love the database and SQL on my team. I absolutely do. And they just get to build more stuff for the service rather than have to tune and mess with the database as much as they used to.
Right. And then there's a request to have a data exchange service for healthcare. I will let you think about that, Jason, about having something for healthcare.
Yeah, I can't speak to everything on the healthcare side. Actually, I've met with the Oracle healthcare team. They have a lot of work going on around data and how to make it make sense, especially around Cerner. But I really can't, I would not do justice to speaking to that in detail. So.
And then here's kind of a futuristic question. Do you foresee knowledge graphs being used in conjunction with semantic searches that when it comes to combining vector search with graph query?
Absolutely. So that language output you saw, we were able to pull from the knowledge graph. Then one of the next things my team is going to do is use the vector search capabilities of autonomous database to vectorize all that language output. And once you do that, that is a perfect bridge to the world of generative AI and LLMs. Yeah.
And the question, as far as I understand, this is limited to Oracle industry app sources and not ERP back office. Is that right? I don't think that's right.
No, Fusion sources could come in here as well. Where we need to, model different, where we need to model different data from either CX systems or ERP systems, we will model it as it makes sense. Fusion has their own solution for bringing all that data together that includes the data intelligence platform. There were questions peppered throughout this about what Energy and Water is doing with the data intelligence platform. So separate from the data exchange, we also are building the first industry solution that pairs energy and water data with Fusion data and the data intelligence platform. So there's a lot going on there to make sense out of bringing back office focused data along with the energy and water industry data together in that data intelligence platform, and where it makes sense to have some entities in the data exchange to help with that, we're all for it. So.
And sort of in that vein is, and we already talked about it, I think, but since the question came up, I thought maybe it might be worth highlighting again. What data did you consolidate? I think you talked about data coming in from different sources. So maybe you could just highlight that once again.
So far for our initial release of this service, we've focused on data from the customer systems, the CIS systems for utilities, specifically for Oracle Energy and Water, that's the C2M or Customer Cloud Service. We've focused on grid systems. So for Oracle, that's the NMS system, but for Maximo's out there as well, that is an example of that. We've focused on data from the O-Power system, which is the customer engagement or EE type platform. And we've also focused on data from the Department of Energy and a few other public sources, Census Bureau. So it's really been focused on that customer system and grid system at first, and O-Power, because we want to focus on getting that customer to grid view as a starting point for the model and where we focus. It seems like such a crucial part of what we need to do in the industry right now. But certainly we'll branch out to like work and asset systems, like work and asset cloud system that Oracle has. So yeah.
But I think I've covered most of the open questions. I think Hans was answering a couple. So, any final comments or remarks, Jason?
No, thank you everybody for joining. Thanks for all the great questions. Super fun to show some of this off.
And maybe you could just switch back to the slides where we have the links to
Sure.
learn more about graph.
Yep. Let me do that.
Oh, and Carrie has just posted that on chat as well. Thank you, Carrie.
Yep. All right.
So just want to highlight that, as Jason said, they'll be working on labs and tutorials for the service. Meanwhile, Oracle Graph feature and autonomous database is available. Oracle Graph does work with on-premises databases as well. And we have links here to product information, live labs. We have a YouTube channel and so on. So please
Yeah,
do
so I want to
check out
reiterate
this graph.
Melly's point. There was a question about cloud versus on-prem. The data exchange is OCI only, but Oracle Graph is both in autonomous and in Oracle database on-prem.
Yeah, exactly. So next slide, please, Jason. Just to highlight once again, the analytics and data community, and I really want to thank everyone there for hosting this session. And you can join these channels to learn about future sessions and so on. And then in the next slide, I want to again remind people that we have an in-person event organized by this community in April in California. So we hope to see many of you there. So with that, we are close to the top of the hour. Let me just check a couple of quick questions. I don't think there are any new questions. So I think, yeah, okay. I think we're good to wrap up, Jason.
Awesome. This was great. Thanks so much, Melly.
Yeah, thank you very much. That was a great session. Really appreciate it. Thank you.